This is my Physics 2211 Lab 2 on projectile motion. So the purpose of this experiment is to demonstrate how the gravitational force and the drag force would affect objects that are thrown at projectile motion. And this data is being measured by comparing the observed motion as well as two separate computational models, one that includes only gravity and one that includes gravity and drag forces. And then through a detailed analysis of including the fundamental principles of Newton's second law and drag force, is to be predicted that the computational model with the drag force included is going to yield a smaller displacement, as the drag force acts in opposite of the velocity of the object, so therefore it's going to greater reflect the observed motion. And the assumptions in this case is that the only forces that are acting on this system are the drag force and the gravitational force, and that this object moves as predicted for a projectile motion. And the system is the ball, and the surroundings are going to be the drag force, the gravitational force from the Earth, and then anything else that's affecting this system. Fundamental principles used in this lab are Newton's second law / the momentum principle, which states that the net force is going to be equal to the change in momentum. So therefore, we're able to create a velocity update formula. It says that the final velocity is equal to the initial velocity plus the F net over m delta t. And then the other two fundamental principles are the gravitational force, which is Fg is equal to negative mg, and the drag force, which is Fd is equal to negative bv squared. And both of these only act in the y direction. And then here's a brief look at my procedure. Basically, I crumbled up a piece of paper and I threw it in a projectile motion way, and I recorded the video, imported this video to Tracker, and then I was able to use the momentum principle to manipulate the GoScript code to create two different computational models, and then I compared all three of these together. Here's the image of the Tracker, the data that I imported from Tracker, and it shows that the object was being thrown at a projectile motion, and then I was able to import this and create a position versus time graph based on the observed motion that I took from Tracker. Then I was able to establish a bunch of initial conditions that would be added into the GoScript code. So firstly, I was able to find the mass, and I put that in the GoScript code, as well as the initial vertical velocity, the initial vertical position, as well as the initial horizontal position. And then since I began my video at the very top of this projectile motion, I knew that the initial velocity in the y direction was going to be equal to 0. So I was able to put that into the vector for the velocity. And then because I knew that there was no net force in the horizontal direction, I was able to find that the final velocity was going to be equal to the initial velocity in the horizontal direction. So I was able to just do the change in position over the change in time to find the initial velocity for the horizontal position. I was able to put that into the velocity vector for the initial condition, and then I was able to take the difference in the time from the Tracker data, and I was able to put that as my delta t. From this, I was able to create my first computational model, just including the gravity. So firstly, I use the gravitational force, and I was able to input g as a 9.8, and I was able to put in Fg as negative g times the mass of the ball, and then I was just put the drag as 0 because there is no drag, and then I inserted the F net just including Fg, and then I was able to use the position update formula and the velocity update formula to update the position and the velocity to reflect this F net. Then here's all the data that I was able to export directly from GoScript, and then I was able to put that into its own graph to create its own position versus time graph, just showing the gravity of this object. Then I was able to create the computational model that included drag as well as gravity. So firstly, I kept all of the updates for the position and the velocity the same because we were only going to be changing the F net in this scenario. And I kept all of the gravitational force objects the same because the gravity is not going to be changing, but I just added in the drag force. So first I solved for V, and that was just plugging in a bunch of different numbers in order to get one that would satisfy being close enough to the observed motion. And then I was able to plug in the equation for the drag force, which is going to be negative b times the velocity of the vector squared, and then since that is only going in the y direction, I just simply added that into the F net vector. So then now it would update the position and the velocity to reflect having the drag force included. So then here are all of the images and the graphs that I was able to export from GoScript, as well as a position versus time graph for the computational model that included the drag as well as the gravity. Finally, I compiled all the position versus time graphs, and I put them on one singular graph to show the difference between the observed motion and the computational models. And as you can see, the computational model that is the closest to the observed motion is going to be the predicted with the gravity and the drag, as the one that simply has the gravity steeps the displacement is much greater in the y direction as comparison to the one with gravity and drag in the observed motion, which are seen to be almost exactly the same throughout. And then on to the essential questions. The only model that would correctly predict the terminal velocity is going to be the drag predicted, as FD and FG act in opposite directions, allowing F net to be equal to 0, allowing for a terminal velocity to be present. And if I were to create a similar experiment that would be designed to finding the terminal velocity of the object, I would just make the initial y value greater, as the ball would have more of a chance and more time to drop down to the ground. And then if this object were just dropped from the initial y instead of thrown, it would have the exact same time, as the horizontal displacement has no effect on the velocity in the y direction. And since gravity acts the same in both these scenarios, it would be the exact same time as well. And a source of error in this lab could be incorrect tracker data, as the initial y velocity was not correct, and any other human error. Thank you.